Okay, let's look at the point 3, which is concrete. So here it says type concrete composite strength considered as follows. So for column and footing, the design strength is supposed to be 3000 psi and it's supposed to be stone chips concrete. For beam, design strength is F prime C is 2800 psi and this is going to be brick chips concrete. And for slab, it is also going to be 2800 psi brick chips concrete. And in third point, it says concrete strength confirmed by trial mixed ratio. So why is the design strength provided here instead of directly giving the trial mixed ratio? This can be a question to those who are from the civil engineering or structural engineering background, or even in the concrete technology section, right? So the concrete strength trial mixed ratio, you know what the mixed ratio for concrete is. It is the recipe for the concrete, right? Okay, so let's say if I give the mix ratio as 1:2:3, something like that, and then when the construction is being done, quality is not maintained, and after doing that, they do not get the desired strength. For example, the design was done considering 3000 psi for column and footing, but after doing that mixed ratio, they are actually getting 2500 psi strength, and because of that, the structure actually collapses. So in order to avoid those kind of mistakes, you just say that concrete strength, confirm it by trial mixed ratio. So they're going to confirm it. You just give them the strength values. So they have to generate this much strength for this members, and then they'll do trial mix again and again until they get this strength. Okay, in order to do that, they may need to do lab test as well. Sadly, in some countries, this is not actually followed. Lab test is not followed. So in that case, what we do is, if we design the column and footing considering 3500 psi, here in this sheet we're going to write 3000 psi. We're going to if we what I meant was, if we design using 2500 psi, then in this sheet we're going to say 3000 psi. So we're increasing 500 here. Okay, we're saying that we actually have designed it using 3000 psi, considering 3000 psi. In reality, we have designed it considering 2500 psi. So even if the quality is deteriorated and the strength actually lessens, the strength will always be in range of what the design strength was. So that's the solution for countries where the tests are not done. For the countries where the test is done, they do not need to, follow those safety procedures, and maybe sometimes they can follow the safety procedures as well. Okay, all right. Right after that, we have minimum cylinder strength based on cylinder test, diameter, height. So if you're going to do cylinder strength to find out the strength of the trial mix, then the cylinder diameter and height is given here, and it says 28 days strength as specified in 3A, and then it says 7 days strength, 75% of the 28 days strength. This two time limit is also given for doing the cylinder test. Okay, right after that, the curing specifications are also provided here. How to cure the RCC work is also given here. And in number 4, we have cement. So which cement should be used is also specified here. The cement should be ordinary Portland cement 1, conforming to BDS 232 and ASTM C150. So this is the code for the ordinary Portland cement type. Okay, so in different countries this code may vary, and there are different kinds of codes. You just need to check the materials, the cement materials codings, and find the desired strength cement that you're going to be needing from those sheets, and then you need to place it here. Okay, so that is a topic that is outside of the syllabus of this course. So let's just say that here you just need to put in the name of the cement that is being used. Okay, so right after that, we go to the concrete aggregates. Okay, which aggregates should be used in the concrete and the specification of that, and we're going to discuss this in the later video. Okay, so that was it for this video. Thank you very much for watching.